Hey guys, all right, here we go again, lesson 111, dividing in scientific notation. So today we're going to be talking about, this is kind of a new concept, but it's very related to something else that we've already done. So you've actually already learned how to multiply in scientific notation. We even reviewed that last week the past couple weeks, whenever we've met for our Zoom meeting and we've done our warm-ups. This has been something that we've looked at, so it's something that I know you are familiar with. So just so that I can just kind of show you what I'm talking about, whenever we take two values or two expressions that are in scientific notation. So for example, 6 times 10 to the 6th power, and we multiply that by another scientific notation value, which would be, in this case, 1.5 times 10 squared, okay? Remember, we use a process called grouping or regrouping, okay? So we are going to take these two values, okay, the 6 and the 1.5, and we are going to group them together in one parentheses. So we're going to be multiplying the 6 times the 1.5, okay? And then we are going to separately group the 10 to the 6th power and the 10 to the 2nd power. Okay, so those are going to get grouped together in their own parentheses. Now, for the first part, we are just multiplying 6 times 1.5, which that would actually end up giving us 9. But then over here, remember our rule is when we are multiplying the bases, we actually take the exponents and add them. Okay, so keep that in mind. That's going to be important here in a second when we talk about what to do when we're dividing our bases, okay? So when we add 6 and 2, we end up with 8, okay? And then we always look back at this number over here when we say, okay, is that proper scientific notation? If we don't see a decimal, we know the decimal's right after it. So that means there's only one digit to the left of the decimal, so thumbs up. It is in the right form. All right, so let's talk about how this applies to dividing. So let's look at our rule, which states when we divide numbers written in scientific notation, we divide the powers of 10 by subtracting their exponents, okay? So that should kind of make sense. If we multiply powers of 10 by adding the exponents, then it makes sense that the reverse of that, dividing by powers of 10, would result in subtracting their exponents, okay? So let's see what that looks like. So if we've got 6 times 10 to the 8th power being divided by 1.2 times 10 to the 6th power, okay, we are just grouping again. We are dividing these numbers. So the 6 divided by 1.2, which if we work that out will actually give you 5, okay? And then when we subtract the 10 to the 8th divide the 10 to the 8th divided by the 10 to the 6th, we are actually subtracting those exponents. So that will result in the base of 10 still, but with an exponent of 8 minus 6, which is 2. Okay? We double check this number over here again. The decimal always goes at the end if it's not there. So that means there's only one digit to the left of the decimal, so we are good. That one works. So it's in scientific notation, so we can write that as our answer. Okay? Let's look at another one. So what if we have 3 times 10 to the 3rd over or divided by 6 times 10 to the 6th. Okay, so same thing. We are going to look at this and say, okay, I can divide 3 by 6, which if we divide that is actually going to give us 0.5, okay? And then we are taking our exponents over here and we said we subtract those. So 3 minus 6 is actually going to give me -3. Now, remember, I said we have to look back at this number. So right now we see the decimal here and we see that there are no non-zero digits to the left of the decimal. So this is not proper scientific notation form. Okay, so you still have one more thing to do here. We've got to move this decimal to where it does have one non-zero digit to the left, okay? So now it's 5.6, which is good, or 5.0, which is good. But if we bump that decimal, we have to allow for that in the exponent, okay? So we have to show that when we want to go back to where we started, we are actually going to have to subtract one more up there, okay? So this is actually going to end up being 10 to the negative 4, okay? Let's look at one more like this. So if we've got 2 times 10 to the negative 2 power, and over or divided by 8 times 10 to the negative 8. Okay, so this one looks a little different because now we've got these negative exponents. And so I'm going to go ahead and warn you here. This is where you have to be so careful, okay? Because I see students make mistakes with these exponents all the time when they're negative, okay? So be so careful. So we are dividing the 2 by the 8, okay? So 2 divided by 8 is going to give us 0.25, okay? Then we are subtracting. Let's write this out, guys, okay? We're subtracting negative 2 minus negative 8, okay? So that minus is separate from the signs of the two values that we see, okay? Because the operation that we're doing is subtracting. Now remember the rule, if we are subtracting integers, we always want to turn it into an addition problem. Only way we can do that is turn it into addition by also changing the sign of the second number. So really what's happening here is negative 2 plus 8, which gives us a positive 6. So this is really going to be 0.25 times 10 to the positive 6th power. Now, remember we got to look back at this number, is this in proper scientific notation? The answer is no. We got to have one non-zero digit to the left of that decimal. So it really should be 2.5. But when we make that move, we have to take one away from our exponent, okay? So then that is actually going to result in 2.5 times 10 to the 5th power, okay? All right, let's look at one more example here. You guys are doing great, almost done. All right, ooh, how did that, let's see. I don't know how that happened. How can I fix this? I mean, I know how it happened. I was trying to make an exponent, but I guess I didn't like that. Okay, so I'll just read it from over here and just fix it because that's actually supposed to say kilometers per second. Okay. So let's just see if I can fill that in real quick. This is supposed to be 10 kilometers per second. Okay. So then what we're really doing here is we are trying to find, let's read the problem and we'll solve it. The distance from the sun to Earth is about 1.5 times 10 to the 8th power meters. Light travels at a speed of about 3 times 10 to the 5th kilometers per second. About how many seconds does it take light to travel from the sun to the Earth? Okay, so if we know that we've got our distance, remember distance always equals rate times time. Okay, so we've got our, what did I just do? Oh my goodness, I'm having all kinds of problems. All right, we're just going to open this up one more time. Let me just see if this will fix things. Well, not entirely, but okay, you got the idea. All right, so distance equals rate times time. Okay, so the distance, which they tell us is 1.5 times 10 to the 8th, okay, equals the rate. So the rate that they're giving us, which is speed. Anytime you see speed, that always indicates a rate, okay? The rate is going to be 3 times 10 to the 5th power, okay, times the time, which we don't know. So if we're wanting to solve for t here, then we need to undo that multiplication by dividing by 3 times 10 to the 5th power here. And if we divide one side by 3 times 10 to the 5th, we need to divide the other side times 3 times 10, or divide by 3 times 10 to the 5th. All right, so that's going to cancel over there. Now here we're starting out by dividing 1.5 by 3, okay? And that's going to give us 0.5. So I'm going to actually go over here where I have a little room, okay? So that's going to be 0.5. Now, when I'm dividing my tens, remember that means I'm subtracting these exponents. So that's 8 minus 5 is going to give me 10 to the third power. So now, in order to, remember, I have to look at this number and I have to say, is that proper scientific notation? No, I have to have a non-zero digit to the left of the decimal. So I can bump that decimal one place, making it 5, but then I have to remember to subtract 1 away from my exponent, okay? Which would actually end up giving me 5 times 10 squared seconds. Or really, this one's kind of simple because we know that 10 squared is actually just 100, because 10 times 10 is 100. So really we could say it's also 5 times 100, which is just 500 seconds. So it doesn't tell us that we need to have our answer in scientific notation here. So really you could just put your answer as 500 seconds. Okay? Great job, guys. So just remember, when you are dividing scientific notation, you are subtracting your exponents. Do that carefully. Pay attention to your signs, and make sure that your answer is in scientific notation. And if it's not, shift that decimal and then make sure you adjust the exponent accordingly. Okay? You guys got it. Happy homework.